Hi. So let's solve this maximum difference between node and ancestor. So first of all, what is an ancestor? Okay. Let's say if okay. So the ancestor means is here 8 is an ancestor of all the subtree of 8 like that. Okay. Similarly, 3 is an ancestor of all the subtree of this node. Okay. So in this case, what would be the possible ancestor for the node 7? These all are the possible ancestor to the node 7, right? So if a node need to be an ancestor of any other node, that means the node must be a parent of the child node. That means an ancestor. I think you guys got it right. So let's see. So in this case, we are given a binary tree, not binary search tree, it's a binary tree. So we need to find what would be the maximum difference between a node and an ancestor. That means, let's say, what would be the maximum value we can get when we taking any of path from this tree like this. Like this is the problem. So let's see what would be the max. For example, what would be the maximum, which one get the maximum, like when we go take this path, what is the maximum difference we can get from this path. Let's take a look. In this case we will get a maximum difference when we yeah, here when we subtract 8 from 3, right? Yes. Similarly, we can take this path also. What would be the maximum difference we can get? In this case, 8 and 1, that would be 7. Similarly, we can take this path. What would be the maximum we can get? In this case, the maximum we can get would be 3 because these two. Similarly, we can take this node, this path, like that. Okay, I think you guys got an idea. Otherwise, please rewatch this video or just search in any YouTube videos or in Google, so that way you can understand. Now let's try to solve our answer. I think you guys got the answer question right. So what I'm going to do is, we know that the maximum difference will be always the difference between the maximum value and the minimum value from a tree, right? Let's say in this case this is a maximum value and this is the minimum value. What would be the difference? In this case the difference is 7, so this 7 would be the our answer, right? So that's the thing we need to find from this problem. So what is the better approach to solve this? Yeah, there's a way that we can check the difference between each node in this list like this, but the problem that it would be face so much difficulty because we need to take into every node, then there's so much time complexity will be arrived like this because we need to search like this, right? Similarly we need to search both of these, so it would be so much messy up. So if there any better way to do this? Yes, there is. So see, Let's take a look at this. We know that the difference is between the maximum value and the minimum value. So what we'll do is, when we go to each node, we will keep track of the minimum till the node, right? Minimum till the node and the maximum till the node. Then we can calculate this. So when we arrive at the leaf node, in this leaf node, we know that in this path, we in this we will get the maximum and minimum values from this path, right? Or if we go through this list, okay, this will be this is our path. We know that when we reach at the leaf node, we will get the maximum and the minimum nodes in this path, right? So that's the thing we are using to solve this problem. So let's see. So now what we are going to do is, let's say in this case, what is the minimum value we can get? It is 8, because the previous value is 8. What would be the maximum value we can get? It is still 8, because it is the root node. Okay, now let's go to this node. What would be the minimum value we can get? It is 3. And what would be the maximum value we can get? It is 8. So this will be, similarly we can go to the left subtree. What would be the minimum value we can get? Okay, so here also another thing is also here, but we are not looking at that. Okay, in this case, what would be the minimum value we can get? Give me a second. What would be the minimum value we can get? It is 3. What is the maximum? It is 8. In this case, what is the minimum? It is still 3, and the maximum is still 8, because 6 is not countable here. When take a look at this, it is still 3 comma 8. And similarly we can do in this case 8 comma 8, because this is the values. When going to here, what would be the minimum value? It is still 8, but what is the maximum value? 10, because 10 is the maximum value. On this case, still 8 comma 14 will be the maximum and minimums right away. Okay, when we reach at the leaf node, we know that we are at the leaf node, so we are getting the minimum out of there and the maximum out of there. We also need to update this from here also, because when we reach at the leaf node, we need to update this. So what would be the minimum from these two? 1. And what is the maximum? It is still 8. Similarly, we need to update from here also. What is the minimum? It is also 3. There is no need to change. In this case, if we need to change, no. In this case, if we need to change, yeah, no, we don't need to change it. So that now what we'll do is, we will just return these two, right? 8 minus 14. In this case, what would be 8 minus 14? 6. We are going to return 6 from here. Okay, so we just return 6 here. Similarly, we have 0 here, because when null occurs, we will just return 0. Then what we are going to check? Now we don't need any of these. We just need only the root values only, right? Okay, now what we are going to do is, we check which one of these is the biggest, then we will return this. In this case, 6 is biggest, so we will return 6 from here. Similarly, 6 from here, because here is 0. Now we got the right side, it is 6. Now similarly we will check what is the difference between this is 7, so we will just return 7 from here. Similarly, what is the difference between 3 and 8? It is 5, so we will just return 5 from here. Similarly, return 5 from here. Which one is the biggest? Both are true, so we will just return 5. Which one is biggest? 7, so we will just return 7. Now which one is bigger? 7, so our result will become 7 because this will return 7. That means our result is 7, right? I think you guys got the idea, right? So let's see how we can implement this in code, and let's expand this. Okay, now what would be the initial case when the list is empty? At that time we just return 0. Then we will just define a helper function to do this work. Then our base case will be when the root becomes null. At that time we will just return 0. Then we will update our minimum and maximum values with the help of our current node, right? Okay, in each level we will update our minimum and maximum values. Then we will recursively go until we reach the left. Okay, then we will store that whatever returned from the leaf in the left subtree will be stored in left, and whatever returns in the right will be stored here. We will pass our minimum value and the maximum value for both. Then what we are going to return is what is the biggest value we can get. Okay, right? If we are at the leaf, that means this will be the maximum value, right? This is for the leaf node only, but this is for all others nodes, right? So that's the thing we are going to do. I think you guys got this while reading this. Okay, so this is it. This much of code only we need. Okay, so similarly we just need to define this function and return it. Okay, initially we just pass the root value as the minimum and maximum. So that's it. That's for it. So hope you guys got understood about this, and if not, just do comment out, and I can improve in the next videos also. So also I am trying to learn, sorry, I'm also learning the whiteboarding things, and so that's why there will be so much errors and misunderstands on this. So sorry for that. Thank you.